This project introduced the fundamental of code quality analysis using SonarQube, a widely used tool for static code analysis. The goal is to help developers understand how to automatically inspect source code and detect common issues such as bugs, security vulnerabilities, and maintainability problems without running the application. In this beginner-level project, you will work with a simple application such as a CRUD API built with PHP or Node.js and perform a local code scan using SonarQube running in a Docker environment. This setup allows you to quickly experiment with real-world code quality tools without complete infrastructure. The workflow is straightforward and practical. First, SonarQube is launched locally using Docker, making it easy to set up and access via a web interface. Then the Sonar Scanner CLI is used to analyze the source code of your project. The scanner sends the analysis results to SonarQube, where they are processed and displayed on a dashboard. Once the scan is complete, SonarQube provides a clear and structured report that helps you understand the health of your code base. The report focuses on 3 key areas. First, issues that may cause incorrect behavior, vulnerability, security-related risk in the code smell, maintainability, issues that make code harder to read or extend. This project emphasizes learning how to read and interpret these reports, which is a critical skill for improving code quality. Instead of relying only on manual code review, developers can use automated analysis to catch problems early in the development life cycle, reducing future costs and improving reliability. By completing this project, you will gain a solid foundation in static code analysis concept, setting up developer tools using Docker, running automated scan on local code, understanding code quality metrics and dashboard. Overall, this project serves as the first step into that set of practice where code quality and security are integrated directly into the development workflow, helping teams build cleaner, safer, and more maintainable software. Demo flow. This guide walks you through a simple demo to scan your local project using SonarQube. These steps are designed to be easy to follow, even if you are new to code quality tool. Step 1. Install Sonar Scanner. First, you need to install the Sonar Scanner CLI, which is the tool used to analyze your source code and send the result to SonarQube. Run the following command. After this step, the Sonar Scanner command will be available in your terminal. Step 2. Run SonarQube with Docker. Next, start SonarQube locally using Docker. Once the container is running, open your browser and go to localhost on 9000 port. This is the SonarQube dashboard where you will see your scan result later. Step 3. Generate asset token. Before scanning your code, you need a token to authenticate with SonarQube. First, log in with the default account, username admin, password admin. 2. You will be asked to change the password. 3. Go to the top right corner, My Account. 4. Open the Security tab. 5. Click Generate Token. 6. Enter a name and click Generate. Copy the token. You will use it in the next step. Step 4. Run code scan. Now move to your project folder. Select environment variable and check installation. Run the scan. Replace your token with the token you generated earlier. Make sure your source code is inside the SRC folder or update the path accordingly. During execution, the scanner will analyze your code, detect issue, purchase, vulnerability, code smell, send result to SonarQube. Step 5. View result. After the scan complete, open localhost online task support. You will see your project dashboard with detailed analysis result. Key things to check: but errors that might break your application, vulnerability, security risk, code smell, maintainability issue. Final result. At the end of the demo, you will successfully run SonarQube locally, scan the real project, understand how to read code quality report. This is your first step toward improving code quality and moving into that set of practice. This project is a simple JavaScript application designed to demonstrate how to use SonarQube for static code analysis. The goal is not to build a complete system, but to create a small, easy to understand code base that can be analyzed for code quality. The project structure is minimal. App main application logic. User handle user-related logic. Sonar project property. Configuration file for SonarQube scanner. This simple step help you focus on understanding how SonarQube works instead of dealing with complete project structure. SonarQube configuration file. The file Sonar project properties is the core configuration file that tells SonarQube how to scan your project. Here is the content. Detailed explanation of each property. Project key. This is the unique identifier for your project in SonarQube. It must be unique across all projects in your SonarQube instance. SonarQube uses this key to store and track analysis results over time. Think of it like a database primary key for your project. Project name. This is the display name of your project in the Sonar dashboard. It is human readable. You can change this anytime without affecting the actual data. This is what you will see in the UI. Project version. This defines the version of your project, useful for tracking trends between releases, helping comparing code quality across versions. Sources. This tells SonarQube where your source code is located. In this project, all code is inside the @rc folder. SonarQube will scan everything inside this directory. If your code is a multiple folder, you can separate them in comma. Language. This specifies the programming language of your project, in this case JavaScript. Modern SonarQube version can auto-detect language, so this field is sometimes optional. However, it is still useful for clarity in simple demo. Source encoding. This defines the character encoding of your source files. UTF-8 is the most common and recommended encoding. Ensure SonarQube correctly reads special character, important when your code contains Unicode character, none enlisted.